Projectile motion problems example number 4. This is the final example problem that we will do on projectile motion. And the first thing that needs to be said is, no, Colin, I didn't spell your name wrong. This was used from last year. So with that out of the way, we begin to pull out our given information. Delta y, again, our height, is equal to 10 meters. And we're given a horizontal velocity of 2 meters per second. Again, as is seeming to be a slight trend, the first thing that is asked is, how long will Colin be in the air? Well, again, as we have in our previous 3 examples, we'll use our delta y is equal to 1/2 gt squared equation rearranged to find t. Once we've plugged in all of our information into 2 delta y over g and then taking the square root of that, we will result with a time that would be the total length of time that our projectile is in the air. Once we've plugged in each step, we end up with the square root of 2 seconds squared, which will actually leave us with a final time of 1.41 seconds that an object is in the air when falling from 10 meters. Our second question asks us, if the pond is 7 meters wide, if Colin will land in the water safely. What we need to recognize from this question is being able to determine whether or not delta x will be less than 7 meters. If it is less than 7 meters, then Colin will land in the water safely. So to do that, we will again use our Vx is equal to delta x over t equation, again rearranged to solve for delta x. Once we've solved for delta x by plugging in our Vx of 2 meters and our time of 1.41 seconds, we'll be able to solve and find how far out Colin went when he jumped off the cliff. Doubling 1.41 seconds gives us 2.82 meters as the total range for which Colin traveled. Therefore, we can safely determine that Colin would have landed safely in the water, since 2.82 meters is less than 7 meters. Now, Colin obviously has a friend, Eric, who is also running off the edge of the same cliff. The only change that we have in this instance is that our Vx has gone from 2 meters per second to 5 meters per second. So we can use the exact same steps that we did in part B. So 5 multiplied by 1.41 will leave us with a resulting distance traveled of 7.05 meters. Well, unfortunately, the pond is only 7 meters wide. So therefore, Eric ends up smashing his face on the opposite shoreline. Again, if you have questions, please make sure that you are going online to our class website and posting them. This way I can get back to you and answer them even though I'm not in class.